Hello, and welcome to lesson 38 of this introduction to calculus with Wolfram U. The topic for this lesson is calculus and programming. So let's begin with a brief overview of the lesson. So the main point is that there are many problems in calculus where you have to do some operation multiple times, tens or hundreds of times. And a good example of that is Euler's method. Now in Euler's method, you have a recurrence relation. What that means is that you need to compute something step by step. So for example, if you want to compute y10, you need to work out y9, y8, etc. And to do this correctly by hand can be very, very tedious. You may have errors in your calculations, or it might just take a very long time. And so of course what you can do is to set up a program which does that for you in the Wolfram language. So that's the theme of this lesson. So in this lesson you'll learn how to make your own programs within the Wolfram language. So we need some preliminaries over here. So we need a few tools basically which will let us make programs in the Wolfram language, and that's just a list of functions which are useful in this context. So you need the function if to control the flow of the program. You also need the simple semicolon character to stop an instruction and move on to another instruction. And you need the function print to put text on the screen and tell you what is happening inside the program. That's what is called debugging. So here's an example of a function. It's called if example, which takes an input a number, and says that if the number a is positive, print positive, otherwise print not positive. So if you apply it to the list over here, if example of 10 should be positive, if example of 0 should be non-positive, and if example of -4 should also be not positive. So here is the output, and you see that although you don't get back anything eventually, you get just back null, but on the way you see the positive for the 10 and the not positive for the remaining 2. Now the next note, if you let's say you say a equal to 5 and you put a semicolon over here, that lets you move on to the next operation, which in this case is a plus 6. So a is 5, so of course a plus 6 is just 11. A couple of things more. So you can put comments in your program using this notation over here. And of course comments are very useful because they explain how your code works. Most code is very hard to read, and unless you have lots of comments, the reader will not be able to tell what's happening inside the code. So as an example, here it's set c equal to 4, then puts a comment to say that we are setting c equal to 4, and then gives the value of c. Now another important function is the for function, which will let you do a task repeatedly like we require for the Euler method. So here's a program that prints the numbers from 1 to 10. So we start with I equal to 1, and you go all the way up to 10, not 11. So you keep going as long as the number I is less than 11, and at every step you increment I by 1 to go on to the next number. And then of course you print the number to say what's happening inside the code. So here is the for loop, and you see it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stops. Okay, just one more issue, and that's the issue of global versus local variables. So the variable over here, a, is a global variable in the sense that its value was set earlier to be 5. Now that can be a huge problem for you when you make a program. So for example, you write a function f of x which just does x plus a, and if you do f of 2, you might think you'll get back 2 plus a, but instead you get back 7, and that's because a is 5. So what we need to do is to instead use local variables. Now you could use different variable names, but you might forget what they are, so the best way out is to use local variables. So for example, over here, we can use module, and what module does is it localizes the variable a. So if I do f of 2, then you get back 2 plus the strange kind of a $2415. Now that number might change from time to time, but basically that protects the a inside the function from being confused with the a which is global. So this extra symbol over here indicates that it is a local variable or a module variable. And that's all we need to define a function which implements Euler's method. Recall that that was the one thing we could not quite discuss fully in differential equations. So here's a function called Euler method. Now I'm using lowercase because the Wolfram language likes to reserve the uppercase letters for built-in functions. So it takes the slope function, the starting point, the end point of the interval, the initial value for the function, and the step size. How many steps you want to take as you go along. So what you do now is you set up a module, and the module has some variables in it. The first variable is m, and what m is, it's just the number of steps to be used. So it's the end minus the start over the step size. We also need the x values, so that's going to be the starting value plus the step size times I, where I will go from 0 to the number of steps. We also need the y values, and to do that we first populate this table with the same constant initial value, and then we start off with the for loop. And what the for loop does is it calculates each value of y based on the preceding value plus the step size times the slope. And then finally we gather all the x and y values and do this transpose to make them look just right. So that is Euler's method from differential equations, now done using the Wolfram language. So with this simple function, we can now try and do some calculations. So here is a differential equation, y prime equal to y with y of 0 equal to 1, and of course the solution for that is just e raised to x. So the right hand side is y, that's your f. So we apply the Euler method to f, starting at 0 because that's where you're starting over here, and you want the value at 2, so that's where you'll stop. And the initial value is 1, that's the one over here, and the 0.1 is going to be the step size. Okay, when you do that, then you see over here that you get back a list of values starting from the initial value and going all the way up to 2 in steps of 0.1. Now you see over here that the last value is 6.7275. So the estimate over here is that the value of y at 2 is 6.7275. Let's compare that with e square, and it looks like it's reasonably good but not very accurate. But that's because we only had a step size of 0.1. Now because you're working on a computer, you can afford to make much smaller steps. So you could say let the step size be 0.001, and then you get back a much smaller estimate for the error, which is 0.007. So point is that you can get better estimates for the values and much smaller errors simply by decreasing the step size. And of course, because it's all automatic, it doesn't matter. You can go quite a long way to get more and more accurate results. Okay, so that brings me to the end of the lesson, and the main point is that the Wolfram language is great for making programs. In fact, what you've done in this course is to learn many parts of Wolfram language in the context of calculus, and that's a great thing. To know programming is a big plus in this age. Now, to program, you need functions like if, for, print, and module. And Do not forget, try and put as many comments as you can because they are crucial for understanding what you're trying to do, both for yourself and for others. Try to avoid global variables, try and use local variables to avoid confusion. And you can do that with module. Now we saw that we can program Euler's method, but of course you can program other calculus operations like finding maxima or minima using the Wolfram language. And to program yourself means that you actually become some kind of an expert on the Wolfram language because those programs can be quite hard to write. So that's the end of this lesson on calculus and programming, and we are really done with the course content. And the next lesson will talk about a sample calculus exam, the first part of the exam. But until then, do review this lesson and be prepared to take on an exam. Thank you very much. I'll stop over here.